Hello there, Mr. Sutton here, bringing you the BC Calculus 517 Extra Practice Number 4 solutions on integration by parts. On this problem, we have a function with a continuous derivative. We're given f of 0 and f of 2, and also the integral from 0 to 2 of f of x, which is kind of nice. They want to know the integral from 0 to 2 of x times f prime of x dx. Okay, well, this is a different kind of story here. So we have a product, and we can't really simplify this because we don't, at the end of the day, really know what f of x does. And we can't use substitution on this either. So if you have a product that you can't do anything else with, we try integration by parts, definite integral style. So I'm going to write the integral from a to b of u dv is going to equal uv minus v du integral. So this setup here. And let me see here now. I need to pick out my u and my dv to get started on this. So I have a choice between x and f prime of x for u. Now, in general, the general philosophy here is we want u to be something that I don't mind taking the derivative of, and dv to be something I don't mind taking the antiderivative of. Well, between these two things, I mean, I could take the antiderivative or the derivative of x, but f double prime, there's really only one way to go with the information they gave us. We know nothing about f double prime. We do know a little bit about f. So if I have to choose, I want to choose u as x, and then I'll let my dv be f prime of x dx, because I at least can take the antiderivative of this and get something I have some information on. So now derivative of x, that's going to be 1 dx. And then antiderivative of the dv here, f prime, that's just going to be f of x. And now multiplying across here, I've got x times f of x. That's going to be my evaluation box from 0 to 2. Minus, now I'm going to have f of x dx inside the integral from 0 to 2. And I can expand this evaluation box a little bit if I want. I don't know the antiderivative off the top of my head of f of x, but I do know a little bit about the integral from 0 to 2 of f of x. So we're actually going to pull that information in just a minute. But let me expand this evaluation box. So I've got 2 times f of 2 minus 0 times f of 0. Still have that integral from 0 to 2 of f of x dx. And now, what is f of 2? Well, f of 2, they told us, is 5. So this is really 2 times 5. And it doesn't really matter what f of 0 is because we're multiplying it by 0, so that's gone. Integral from 0 to 2, they gave us that. They said that was 7. So we have a minus 7 here. So this is just 10 minus 7, which comes out to 3, giving us answer choice A. On this problem, I'm trying to take the definite integral of a product that I can't really do anything else with. So because there's nowhere to go with this product, I'm going to try integration by parts. So let me write the general formula. We have integral of u dv equals uv minus integral of v du. And I have some evaluation boxes and a's and b's to go along with all this. So now u and dv, I have to pick those out in the beginning. I have a choice between an algebraic function, 4x plus 5, and this exponential e to the negative x. Now, using my acronym of LATE, L-A-T-E, I know that a comes before e, so I prefer to have algebraic for my u value, and I prefer to have an exponential for my dv value. Exponential doesn't get any worse when you take the antiderivative, and the algebraic gets better when you take the derivative. So let's let u equal 4x plus 5, and dv is going to be this e to the negative x dx term. Derivative of u, du, this is going to be 4dx. Antiderivative of e to the negative x gives us a v value of negative e to the negative x. And now multiplying across here, I've got 4x plus 5 times negative e to the negative x. That's going inside this evaluation box. So that's right here. This was just me pretty much rewriting the original. And then, let's see here, I need to do minus the integral now of negative e to the negative x times 4 from 0 to 2. All right. So taking this a little bit further, I have this original bunch of stuff that's still in my evaluation box, hasn't changed. But now I need to take the antiderivative of negative 4 e to the negative x. That would normally be positive 4 e to the negative x, but I already have a negative out here. So that just becomes negative again, negative 4 e to the negative x. That goes in the valuation box because it's also going from 0 to 2. And now we just have to actually plug stuff in and evaluate this stuff. So before I do that, just to clean things up a little bit, if I distribute this e to the negative x times this parentheses, I'm going to have a negative 4x e to the negative x. And I'm also going to have, let's see here, this is going to be a negative 5 e to the negative x, which when I combine with this negative 4 e to the negative x gives me a total of negative 9 e to the negative x. Just doing this so it's a little bit easier to plug things in, because I actually do have to simplify this thing to get one of these multiple choice answers. So now I have this stuff with 2 plugged in, minus all this stuff with 0 plugged in. All right, well, let's clean up this left bracket here. This is negative 8 e to the negative 2 minus 9 e to the negative 2. Well, hold on a sec. That's actually going to just be negative 17 e to the negative 2 when all is said and done over there. So we can clean that up a little bit. Now over here, this first term is getting zeroed out. For this next term, I have negative 9 times really just 1. But we're subtracting everything in there anyway, so this becomes a positive 9. And then this is going to end up giving me answer choice B. For this problem, I'm trying to take the antiderivative of this product. Since there isn't really anything else I can do with this, I'm going to try integration by parts. So that's integral of u dv equals uv minus integral of v du. Let me pick out my u and my dv to get this started. So for u, I prefer to have an algebraic, like 18x, over a trig function like this cosine of 3x, because if I pick u for 18x, that's going to be easy to take the derivative of. And if I pick dv as cosine of 3x dx, well, that's at least not going to get worse when I take the antiderivative. So taking my derivative over here for u, this is going to be 18 dx. Antiderivative of cosine of 3x, my v value, that's going to be 1/3 sine of 3x. We have to divide by that inner tail there. So multiplying across for uv, this is going to be, let's see, 6x sine of 3x. And then minus, we have the integral of 6 sine of 3x dx. So I have that 6x sine of 3x initially. And now I have the antiderivative of this, which, let's see, antiderivative of sine is negative cosine, but we already have a negative, so that's going to be positive. I also have to divide by this 3, this inner tail, so that's going to be positive 2 cosine of 3x plus c. And let's see here, that ends up giving us choice A. For this problem, I'm given some selected values of some function h, and we have h, h prime, and h double prime. They gave us a whole bunch of stuff here. Based off of this, we want to know the value of the derivative of the integral, rather, from 1 to 4 of x times h double prime of x dx. Well, what we've got here is a product that we can't really simplify. Substitution's not going to help us either. So really the only recourse here is integration by parts. So let me set up my general formula. We have integral from a to b of u dv. It's going to be a valuation box of ub minus integral from a to b of v du. So this is our integration by parts dance that we're going to have to do here. To start off, I need to pick out my u and my dv value from what we have in the original. So in general, I like u to be something that I can take the derivative of, and dv to be something that I can take the antiderivative of, and it'd be nice if they didn't get any worse when I did those things to them. So x could go either way, but it's probably going to get nicer if you take the derivative of x. So I'm thinking x is a pretty good choice for my u value. H double prime, we really have no choice making this the dv value, because, I mean, if you take the derivative of h double prime, you're going to get h triple prime, and, I mean, what are you going to do with that? They didn't give you h triple prime in this table, whereas they did give you h prime and h without any kind of prime. So let me let my u value be x. dv is going to be h double prime x, h double prime of x dx. And then for du, we've got 1 dx. For v, antiderivative of h double prime is just going to be h prime of x, which we've got at least some information about. Now multiplying across here, we have x times h prime of x evaluated from 1 to 4. That's this uv a to b box there. And then we're going to be subtracting the integral from 1 to 4 of just h prime of x dx. Okay, so I'm going to be able to put everything together inside an evaluation box on this next move here. I've got the stuff that was already in there, and now the antiderivative of h prime of x is just h of x. That's pretty convenient. So we have just minus h of x from 1 to 4. And at this point, it's time to plug stuff in. So I've got all this stuff with 4 plugged in, minus all this stuff with 1 plugged in. And let's just go through and clean this up a little bit. What is h prime of 4? Well, looking that up in the table, that's 5. So this is going to be 4 times 5. What's h of 4? That's going to be 10 according to my table. So we have a minus 10 here. And over in this other bracket, we have h prime of 1 to deal with. H prime of 1 is 4. So we have 1 times 4 there. And then we're subtracting h of 1, which in the table back here is 3. So minus 3. Cleaning things up still more, this is going to be 20 times 10, or minus 10 rather, which comes out to 10. Over here we've got 4 minus 3, which is 1, and we're subtracting that. So careful now, 10 minus 1, this is going to be 9. That gives us choice A. On this problem, they just want to know which of these is equivalent to the integral of x times e to the x over 2 dx. And if you look at these answer choices, at least 3 of them kind of look like an integration of parts kind of setup. So that's the direction we're going to go here. The formula for integration by parts, which works well when you have something like this with a product that you can't do anything else with. You've got integral of u dv equals uv minus integral of v du. So now u, in this case, I have a choice between an algebraic and an exponential. Algebraic, we know, works better for the u value. Because it's easier to take the derivative of an algebraic than it is to take the antiderivative, and that's what you have to do with this u down the road. So I'm going to let u be my x value, and then dv is going to be e to the x over 2 times dx. Derivative of u is going to be 1 dx, and my v value, antiderivative here, is going to be, let's see, I have to divide by this 1/2 tail in here, so it's really multiplying by 2. So v is going to be 2e to the x over 2. Multiplying across to get the uv part of this, I've got 2x e to the x over 2. Minus, now I have the integral of 2e to the x over 2 dx. And I mean, the funny part about this is I actually could take this antiderivative pretty easily, but I don't have to because it's already in one of the answer choices, choice B. So we're just going to stop there. For this free response problem, we have f as a function defined for positive numbers. F of v is 2, and f prime is given by this function right here. We want, for the first task here, an equation of the tangent line at the point e comma 2. So I'm going to use point slope for this. Y minus y1 equals m times x minus x1. And I actually already have the x1 and the y1. They gave us the point here. I just need the slope at that point. So to get that, I'm going to plug the x value e into this x squared ln of x formula here. So that's going to be, let's see, ln of e is just 1. So this is just e squared when the dust settles. Plugging everything back in here, we've got y minus the y value of 2 times my slope that I just found of e squared, that was this f prime of e piece here, times x minus the x value of e. And there's no need to simplify, we are just done. On this problem part, they want to know if the graph of f is concave up or down on the interval from 1 to 3 and give a reason. So probably the easiest way to do this would be to figure out a formula for f double prime and then do a little sign analysis to see if it has to be positive or negative on the interval from 1 to 3. So for f double prime, we're going to need the product rule. So that's u prime v plus uv prime in general. Let me set up my box and ribbon to help negotiate this. So I have my u value of x squared, v value of ln of x, just the two factors, and their derivatives, u prime and v prime, are going to be 2x and 1 over x. Multiplying all that back out, we've got 2x ln of x plus, and this is going to be x squared times 1 over x, which I can just reduce to x. So this is what we need to do our sign analysis on. It'll be a little bit easier, I think, if we factor an x out of all this. So that'll give us 2 ln of x plus 1 in a parentheses there. And now just taking a look at this, remember, we only care about what this is going to become between the x values 1 and 3. So on the interval from just 1 to 3, we only have two factors here. The first factor, x, is obviously positive because the numbers between 1 and 3 are positive. How about 2 ln of x plus 1? Well, ln of 1, the bottom of this interval here, is going to be 0, but you're adding 1 to that. So already that's going to come out positive. And if you plug in something bigger than 1 to ln, you're just going to get more positive numbers. So overall, this 2 ln of x plus 1 expression has to also come out positive on this interval from 1 to 3. So if you've got a positive times a positive, overall then f double prime is positive on this interval. Therefore, that means that f itself must be concave up on this interval from 1 to 3. On this last problem part, kind of the final boss battle for this one, they want us to use anti-differentiation to find f of x. Well, this is kind of a diff-EQ sort of problem because we've got the differential equation, basically f prime equals x squared times ln of x, and we also have an initial value, initial condition of f of e equals 2, so we're going to use these to figure out f of x. So I need to take the antiderivative of f prime here. To do that, though, since I have a product that I can't really do anything else with, I'm going to have to use integration by parts. So my general formula, integral of u dv equals uv minus integral of v du. I'm going to use this setup here. My u and dv values, I'm going to pick those out in the beginning. So I have a choice here between an algebraic and a logarithmic function. Now, according to my little acronym I use of LATE, L-A-T-E, a logarithmic, L, is a better choice for u than an algebraic. Not many things are a better choice than an algebraic, but L beats an algebraic out, just in terms of, ease of taking derivatives and antiderivatives. So let me let my u value be ln of x, and then dv this time around is going to have to be x squared dx. So now let me do derivative of u, which is 1 over x dx, and antiderivative of dv, that's going to give me 1/3 x to the third power. So multiplying this out to get uv, we've got 1/3 x cubed ln of x minus, let's see, we have an x dividing into the x cubed. That's going to give us an x squared. So we've got minus the integral of 1/3 x squared dx. And I can go a little bit further here. This antiderivative, this bumps up to a 3. Dividing by that, we have 1/9 x cubed. And we have a plus c. Don't forget about that. So at this point, we're going to plug in our initial condition, e comma 2, to figure out what the c value is. So I can write that f prime, which is going to be the 2 in this case, or actually f, which is going to be the 2 in this case, because this is f of x equals all this. So 2, the output, equals all of this stuff over here with e plugged into it. And let's clean this up a little bit. So ln of e is just 1. This is 1/3 e cubed minus 1/9 e cubed. Well, that's really 3/9 minus 1/9, or 2/9 e cubed. And let's see here. To get c, I just have to subtract. I'm not going to try and combine these. I'm just going to write 2 minus 2/9 e cubed. I'm almost there. All I have to do now is replace the c right here with 2 minus 2/9 e cubed. So at the end of the day, I have f of x equals 1/3 x cubed ln of x minus 1/9 x cubed plus 2 minus 2/9 e cubed. Whew! And we're done.